Hello everyone, welcome back to my Unreal Engine open world tutorial series. So today I am going to show you with a parameter like this is a material collection parameter, how to make these trees that I have placed as instanced foliages, how to make them bend like this. So as I keep increasing this wind vector, you can see the trees are bending to reflect that wind direction like this. If I make it 1000, it will be like this. If I make it minus 1000, it will be bent in the other way like that, like this. So it works on all the directions, this way and the other way as well. So you can define any direction as the wind direction. So yeah, this at this stage this doesn't look very realistic, but I want to show you how to. This is the point I am going to start developing this wind reaction system for the global wind for these foliages and grass and everything. And as always, this episode is sponsored by these generous Patreons. Thank you very much for the support you guys are giving me. Right, so all of these trees are, I have placed them as in using foliage tool as instanced static meshes. So some of the nodes that I can use inside materials don't work exactly as you would expect in a static mesh. So yeah, today I'm going to do a research on how to bend this tree to react to the wind. Just like these grass react to the wind, I need some kind of a reaction from these trees as well. Okay, so for that, actually this is what I want to do. From the root where the tree is connected to the ground, the tree should not do any bending. It should bend as it goes upward. So yeah, how to determine whether this tree is going upward, whether this is a point that is in upward direction from the root. So yeah, let's start. So this M is stylized. This is the master material of these trees, of this all the trees that I have used here. mm, right, so okay, so in order to get the distance from the root to the whatever the pixel that I am rendering at the moment, we can get it using this node pre-skinned. Well, before that, let me demonstrate this with just a normal static mesh like this. Okay, so I'll create a material m test and I'll assign m test to this object. So here I can get absolute world position, and here I can select absolute world position including material shadow offsets. Okay, I'll select that and I'll add a mask Here I'll select only B because I'm interested only in upward direction, and connect here as the base color. Now as you can see, here if I apply this material to this object, you can see it is still no, let me make this one unlit so we can clearly see. Right, so it's all black. That's because the location of the vertical location of this object is in minus. So if I make this one, or if I move this object upward like this, oh, if I do it like this, it will take forever. Let me just set it here. Right, now as you can see, when I set the object position to 0, all the points above this, above the 0 position, above the pivot is white, and everything else is here black. That's because I get plus values for whatever the pixel that I am rendering above this point, and I get minus values as the B input for whatever the pixels that I am going to render here. So now what I need is not this one. I need whatever the position of this object, I need it to be in the middle, let's say from the pivot. In this case here it should be above this point white and below black, whatever the position of this object is. So for that we can do this, can get object position world space. Right, we can get this, and we can subtract this from the object position and connect here and apply. Now it is still looks like this, but even if I move this object, you can see still that change remains, that the color remains the same even if I move this into negative values. Let me put this back on the ground. Oh, right. Okay, so I can place this one like this. Now you see the light difference, the color difference. Okay, so now what I need to do is, instead of getting this direct black and white change, I need some gradient. So to get a gradient, I'll divide this value by a parameter, let's say 1000. Is it too much? What about 100? Yeah, 500. Okay, right, now you can see there is no direct black to white change. From here to here it gradually changes from black to white. Okay, now using this property, I'm going to bend this object towards the wind direction, and I have this wind Let me show you. I have defined this wind direction parameter here in my MP global material collection parameter collection. So yeah, now here I'll get a reference to that collection parameter. I'll select, I have already selected by default MP global, and I'll use this wind direction and multiply this with this one and connect to world position offset. Now you can see some kind of a bend is here. Yeah, now you see, even if I haven't deformed this object static mesh, you can see this object is bent to the red arrows direction. That's because of this wind direction parameter. Now if I increase this, you can see this is further bending like this. Okay, so now I don't need it to bend to the opposite direction if I am, so that means the black area should remain constant without bending. So for that I'm gonna have to clamp this like this. For minimum value I'll set 0. For the maximum maybe let's say 500 units. Right, now let's see how it behaves. Right, now you can see the white area bends but not the black area. Okay, and yeah, that's correct, but also I need to have some kind of a curve here instead of having a straight bending like this. So I can achieve that if I, yeah, maybe here I'll multiply this with itself and feed here, so I get a square instead of, oh wait, no, that's not correct. Yeah, what if I multiply here with itself? Okay, that's, it seems that's too much, but I can, no, it's not working. Not good. Oh, okay then. Let's try multiplying at this point. I just want to see what happens if I do it there. No. Okay, so in order to get a curve, maybe let's promote this to a variable. Let's call this one, but gradient default value should be, let's try 20, and then yeah, I'll disable this clamping for now and have directly connected it here. What else I can, right, now apply, and let's create an instance of the same material and apply it to this one. Right, now let's change, let's set the wind to 100. Where, what happens if I change this gradient? Nothing much. Well, let's forget about the curve for now, and now let's see what happens if we apply the same technique I have used here to the instanced static meshes. Alright, so that means the base material of this bark or this tree, so that is this one, M stylized. So actually I have used this M stylized for these rocks as well, but I don't need the rocks to bend if there is a wind. So therefore we can create a new material, but yeah, I think we can manage that with the parameter. So if it is yeah, if it is the rock, we can add a multiplier to make the bend in 0, right? So what I have done here is this. Okay, I'll delete this and this too. At this point I am only interested in this color. Let me break this world position as well. So right, so I only need to get this color variation for the instanced static meshes. So I'll copy this into here, and as for the base color, I'll connect this. Right, now let's see. Right, now as you can see, all of these trees are black. It doesn't have the white like this static meshes. That's because these are instanced static meshes, so this absolute world position doesn't work exactly as on a normal static mesh. So for that we have another node that we can use, and that is called pre-skinned local position. So this is since this is the local position, I don't even need to subtract this object position. I did this far because I want to explain what's the difference between the instance static meshes and how, yeah, basically why can't we apply this method here. So for the instance static meshes we have to go with this. So if I connect this, you will get this error, pass through custom interpolators if needed. Right, so for the colors we can't use this because this works only on vertex shaders. The color is also a component of a pixel shader, I guess, so therefore I'll disconnect this one and use it here for the world position offset and apply. Right, now okay, now if I have done everything correct, the tree should bend if I increase the wind. So let's see. I don't see any difference. Did I apply this? Oh, I haven't applied this. Okay. Still no. Right, let's open the... Yeah, maybe this gradient is a little too much. Let's try 1 and apply. Okay, alright. Now I get the bend in trees. Oh, wait. Right. I forgot about this part. Okay. Alright. Oh, now it seems the bending in the trees are a little extreme, because when I set it to 1 it is already bent all the way. If I set it 2 it's like this. Okay, what can I do to reduce that? Maybe here let's multiply this with itself and use it. It's still too much. Alright, one more thing. Let's increase this gradient again. Right, now it's better. So when I have wind 10, it is bent like this. Well, this is not very realistic, and also we need to do something about these leaves as well. I'm just showing you the method. So we have to polish this in order to use in a game. Okay. Now this is the material instance of the of the tree, not the material instance, base material instance. So here maybe let's see change in this gradient parameter to, yeah, 200. Now with greater wind values also it works like this. Yeah, let's try 1000. Okay. Okay, 1000 is better, I guess, for a tree. Yeah, and I'll stop this episode at this point. So in the next episode, I'll show you how to keep these leaves attached to the branches of the tree as the tree bends to the wind. And if you like to support my work, you can get the membership of my Patreon club. Link would be in the description below. And also, I have released a new episode of my third person shooter series. Feel free to check that. And thanks for watching. See you in the next episode. Goodbye.